Good morning, everyone. So this is my third opening keynote at the DPE Summit. So my keynote today will be straightforward. No neuroscience research this time, no insights into knife sharpening and workers at meat factories and how that relates to software development. So the reason is we in technology sometime are missing the obvious foundational problems. Maybe because they're not sexy, maybe because it is embarrassing that we don't have a solution for them. And the software supply chain is a very good example for this. And the alpha and omega is simple observability or the lack thereof, right? And I really mean simple. How many builds your organization is running locally in a week, right? For example. And I feel where we are as an industry is still far away from having that simple observability available. And I feel like that we're not fully aware of the pointlessness of trying to improve something as complex as the developer toolchain without being able to observe it in depth, right? And while in principle everyone agrees, right, when I talk with them about it, what I still don't see is the urgency to change that. And when I think about why this is the case is that it might be still too abstract of a concept to create enough urgency to establish that within their organizations, right? And I hope to change that this is something so obviously necessary for everyone that there shouldn't be a keynote about it because everyone has it, right? So this keynote, I want to make it a little bit less abstract, so give you a lot of good ammunition to make the case that coming here next year, right, everyone has that foundation. So you don't need to make that case for your production environment, right? Everyone has observability in production. But 15 years ago, we were in a similar state as we are with the supply chain observability or the toolchain observability today. No observability, basically. You ask an ops team, how long does it take for the shopping cart to be shown? And the answer was, good question, I would like to know myself. And today you would get fired for not knowing this and for not monitoring it and for not actively complying with an SLA that you, I'm sure, have around that. The urgency for this was obvious. It was directly affecting revenue. But we have a high urgency as well in our space, but the implications are less understood. So, but this should be the vision, right? This is from a book from Michael Nygaard. The tools, services, and environments that developers need to do their job should be treated with production-level SLAs. The development platform is the production environment for the job of creating software. And who would not agree to that? But this is the talk. Where is the walk, right? And we say, this is great, but I don't know how many builds my organization are running. I don't know how many failures I have per week. I don't know what my dependency download time is. Then, no, you're not treating it as a production environment, right? So, and from a business impact, though, this is a no-brainer once you understand the implication, right? Toolchain observability is either the foundation or a core component for all of those: DX, developer productivity, time to market, DORA, working in small batches, which is one of the key principles of DORA, shift left, security, efficiency, developer culture, all of that, right? So when I look at toolchain observability, right, I hear this very often, right? But then the question is still, why do we need it for, right? And I see four major buckets, right? One is governance and security incidents. The other is feedback cycle time. The third is usage insights beyond security and governance. And the fourth is pipeline reliability. And I will talk to all of them. Let's start with security and toolchain, right? How fast and efficient can you address a newly surfaced supply chain vulnerability? And how can you constantly keep evolving your toolchain to have a minimal surface area with modern versions or up-to-date versions to reduce the probability of being affected by one, right? So the Log4j incident was a wake-up call, I think, for the industry, right? It was extremely painful to address. It took a long time to fix the vulnerability, and it took most organizations a huge amount of engineering resources to do so. And that's something to keep in mind when we talk about security. Every security incident when it comes to the supply chain, the tool chain, is also a huge risk for your developer productivity if you're not prepared, right? So currently the primary focus on supply chain attacks is a lot around libraries, right? But it's so much more than that you need to be aware of. It's your IDE, source control, build tools, build tool plugins, CI systems, CI plugins, artifact repositories, the JDK used to build the software, the machine used to build the software, testing frameworks, mocking libraries, the list goes on. All of those are dependencies, right? If there's a problem with any of those, right, you cannot get things correctly deployed. And if there was a vulnerability in any of those dependencies, the mocking library, the build tool plugin, it will affect your production application, right? So my question is, who of you could easily do a reverse query? Hey, I need to find all services and applications that are in active deployment that have been built with Maven compiler plugin 3.6.2 and has used Mockito X as a mocking library. Who of you could easily answer that question? So that's maybe 1%, right? So who thinks it would be a good idea to be easily answer such a question? Okay. It's interesting, only 50%. So it might be morning inertia, right? Yeah, if not, interesting, right? So because if you cannot easily answer this question, how can you easily address such a vulnerability, right? And the reality is, most organizations don't have a semantically rich model that captures that information in real time. And one thing when it comes to toolchain observability that is very, very important, right? It is not enough, and security is only one area where this is important. It's not enough to just capture what are the declared dependencies in some configuration file. What is the dependency declared in a POM XML or build.gradle or wherever, right? This is not a source of truth, right? Things might get overwritten by some mechanism somewhere in between. What we mean with toolchain observability is always analyzing the toolchain in real time, whatever it is actually doing, right? And capturing the real behavior that happened at that moment in time. And that is the source of the truth. And that is in particular important for those kind of governance and security incidents observability that you need, right? So for me, having this observability, really treating every part of the toolchain as a dependencies, being able to find out which of your repositories and which of your deployed applications and services have been exposed to any of those dependencies is a must for any organization at scale, right? So the threat is real and can come from any element in the toolchain, right? So who heard about the XZ utils backdoor from earlier this year, right? And you know, the build system was the entry vector, right? They manipulated the build system to create a very sophisticated attack vector, right? And fortunately, it was accidentally discovered. Otherwise, it would have been a major global security disaster. This is happening. I also remember it was years ago when the fifth most popular plugin for Eclipse was a malware plugin. Some decompiler that was also doing malware activities. And yeah, it was running in many of organizations like yours, right? Okay, so this is something, it's a no-brainer, right? What we're seeing, there is a lot of attention in the industry right now to solve that, also because of regulatory pressure, right? And the nice thing is, right, this data, once you start collecting it, right, the same reverse queries can be interesting if you want to do a breaking change for a library. Who is using my library version 3.0 because you want to upgrade it to 4.x, but you want to see whom you are breaking, right? Reverse search for the supply chain is absolutely necessary for protecting against supply chain attacks, but it brings a lot of other benefits to make it much more efficient and easier to understand what is downstream so that you can assess if you change X, who is affected by that. So the other big part of observability is feedback cycle time, right? So, that's pretty obvious, but I want to share a couple of examples, right? So once we started doing this at scale with large organizations, for example, one thing that we're seeing that many larger organizations with thousands of agents and 10,000s of repositories, what we're seeing is that 90% of CPU time, easily 90%, is unused. 90%, right? So there would be a typical setup would be that most of the 10,000 repositories, they get a standard CI agent assigned, let's say with 20 cores, right? And everyone is getting 20 cores unless you're a very special project, right? And what we could see is that 90% of those cores are idle, right? So that means builds that need more cores don't get them. They still have a lot of queuing issues, right? They have all these unused resources, but it's blocked by builds, CI builds that don't need it. And number 3 is many builds are misconfigured. They're not using the parallel options. So while they could be much faster, just someone needs to put on a damn parallel switch for your Maven build, for your Gradle build, right? But it's not happening, right? I mean, it's a shit show, right? So, and boy, those CI environments will be so ready for the code growth coming from generative AI. Don't you agree? Yeah. So the good thing is that once you have this data, you're not just able to surface this extreme waste of resources, the data can easily be used to fix it. If you have detailed data about how all the builds are run, you can use this to dynamically assign agents that neither over nor under allocate resources for a specific repository. A Maven project with one submodule doesn't need 20 cores, right? So you can change the parallel configuration for the misconfigured builds. It's so easy. No one is doing it. What's going on, right? So needs to change. And what's going on is no one is aware of it. Everyone thinks, yeah, somehow probably it's not optimally utilized the CPU resources. No one had an idea about the scale. And once you do this, the results will be spectacular, right? You can increase your CI capacity by 10x possibly. So that brings me to another topic. CPU and disk I/O are such fundamental resources and constraints for running builds and tests. So what we see over and over again is people wonder why their build is slow, right? And they come to some wild conclusions. We had one incident, I guarantee you, 1,000 submodule Maven build, right? People were thinking about a year-long build migration because their build was slow. But it turned out to be primarily a disk I/O issue on CI. And once we surfaced that information, it was a very easy fix, right? It was a fix within a day versus multiple years of a lot of engineering resources. And what we're also seeing all the time, people doing migrations from one CI product to another, and then comparing apple with oranges because disk I/O is not the same for the different CI products. It's just when you don't have the basics, it's so hard to reason about anything, right? And CPU and disk I/O, very important. So we are very excited that in the latest release of the Velocity, we have added CPU, memory disk, disk I/O speed, network profiling information to the timeline view of build scans, right? And another example, we had this one org, and it's an interesting one because this is about culture, right? With this one org, where their builds were extremely slow on a Saturday. Usually Saturday is the best time to get anything to the pipeline, right? So this was the exception, right? And the developers were completely confused by that. And by looking at CPU time, we could see that the CPU load outside of the build massively increased on Saturday. So it turned out that this was the time when a lot of updates were applied. No one in development knew about that. And in this case, there's nothing to improve. That's just how the organization works. But it has increased the trust and the predictability into the toolchain by the developers. This is so important. When the developers don't trust the toolchain, right, when it does whatever it wants, there's no explanation, no one knows why, right? This has major implications on the behavior of your developers. It deserves a whole dedicated presentation, but I claim that a predictable toolchain where the phenomena are understood, right, is important for a healthy development organization, right? And it has many, many negative effects if you don't have that. So next thing I want to talk about, ephemeral CI. I was always fascinated how ephemeral CI was introduced, right? So you make a huge disruptive change to a production resource, which is mostly developers, right? Organizations paying the large organizations billions or tens of billions of dollars, right? Just in direct cost, right? And you would think, before I make that change, let's measure the impact, right? Let's measure the impact it has and see whether it's worth it and how we can mitigate it. Well, we don't have the data. Just push the button, fire and forget, right? No responsibility, no accountability, right? And that's exactly what happened across the industry, right? And I'm sure this has cost the industry tens or hundreds of millions of dollars over the last 5, 6, 7 years. But it's dark cost, not measured, not quantified. So what? And now we're starting to surface and quantify some of that dark cost. And one obvious aspect of ephemeral CI is the increase in dependency download time. So everyone knows it, right? Who is excited about the dependency download time? This room. Yeah. But no one is able to quantify it. I cannot tell you how many booth conversations. Yeah, we introduced ephemeral CI. Dependency download time is so long. And then my question was, how long is it? Well, I don't know. Every conversation went like that. I'm talking about that includes very companies that are advanced and definitely considered advanced at the engineering level, right? So what we have been able to measure across many large organizations is, I think, remarkable. 30 to 40% of all CI build time at large organizations is spent downloading dependencies. 30 to 40%, right? And that is one explanation for the idle CPUs, obviously, right? So now you at least can quantify, hey, this is no longer anecdotal, this is quantifiable, right? And you can make a business case. So a big part of useful toolchain observability is to give you the big picture, but then also allows you to drill in to find the root cause, right? So you want data that tells you, is it a problem of network speed? Is it a problem of the number of network requests? Is it a problem of getting a lot of 404s from other factory? There are quite a few dimensions to dependency download time. And if you can break it down, if you cannot break it down, you cannot fix it, right? So what we have seen in general that for CI builds, the problem is not so much network speed, but the number of requests to the binary repository. So the solution is to reduce the number of requests, right? Faster network will not help you, right? For local build, situation is different. So, we're working on a solution for that. But it's a huge problem. And one thing I want to mention in this context, when we talk about toolchain observability, we have so far focused only on CI, and most organizations only focus on CI. They have shitty observability on CI. They have no observability for local builds, right? And so the local experience is like, I don't know, being in some private prison, some part of the world that no one pays any attention to, right? And then everyone wants to shift left. Great. So, and it's not just about dependency downloads, right? So I never forget that we worked with an insurance company and looked at their builds and test times, and they only looked at CI build times, said our CI build times are great, right? A minute, 45 seconds. Once we started collecting data from developer builds and tests, we found something interesting. We saw local builds took more than 20 minutes, right? For the same project. So digging in deeper, we found that those builds come from developers that work from home and use a network share for the build output directory. Okay, that happens. No problem, but it's good to know about it. For the developers, it was normal. No one complained. And I guarantee you, wherever we look, what is happening with your local build experience to your developers, it's once you surface that, it's like, oh my God, oh my God, oh my God, oh my God. And a lot of that is easy to fix, right? But you need to know about it. And it's not enough to fix it once, right? It needs to be monitored. It's your production platform, right, for creating software, isn't it? Right. So another good example is people using a remote build cache for their local builds, right? Great, right? But at this organization, it was an open source project in this case. What no one realized was that the cache for most of the local developers was misconfigured. So they were getting exceptions, cache node not found. So, but the build doesn't fail, right? Gradle build tool tries 3 times, and then it just runs the build without a cache. So everything seemed to be fine, except that their potential cache savings were like terrible because hardly any local build was using the cache. So without observability, using any back-end technology like build caching you're missing out a lot on the potential savings and possibly introducing negative savings. So again, shift left without local toolchain observability, forget about it, right? It will be just talk. So let me move from feedback cycle time to usage insights. So when we talk about usage insights, sometimes people say, oh, it's nice to have, right? So, it's a must-have for security, but I think it's a must-have also beyond security. So one of my favorite examples are migrations, right? So developers do a lot of migrations, right, from one library to another, major version updates in libraries, CI systems, build tools, etc. And with migrations, you always want to do the following, right? Figure out who needs to migrate, what is the progress of the migration, and are there any issues introduced by the migrations? It's pretty simple, right? So, but what do people do nowadays, right, if they don't have that? So typical example is CI migration. We like a lot of companies that move from CI product A to B, right? So, and because they don't have toolchain observability, what they do is they measure everything by project. So they measure the progress of the CI migration by how many projects have migrated. This is not a good measure, right? Because you have tons of zombie projects, you have very big important projects, you have very small projects, and you might think, hey, the migration is going great, right? We have achieved, let's say, by July 7, 60% migration, right? But when you look at CI build volume, it's only 15% migrated, right? And that is a problem we see all over the place. You cannot measure properly progress of any kind of migration. So, and that is often the reason why some migrations are not even started. Some migrations are people are frustrated because they think they're not making progress while they actually made a lot of progress. And then the other thing is quality of service, right? So are there new types of problems for the migrated usage? And most organizations are not able to answer this. They just say, we do this migration and then, like ephemeral CI, fire and forget, right? That is the new reality. Might be as shitty, might be shitty, or might be a little bit better than before. We don't know. So I want to share a story that underlines that. A large organization is in the process of migrating their CI product from A to B. And I was talking with their very competent CI team and CI engineering lead. And he said, well, quality of service doesn't matter. I was like, why doesn't it matter? Well, the migration is mandatory by executive decision, right? So developers don't have a choice. Everyone has to be migrated by the date X. My ass is on the line. Just put in numbers of how many projects have migrated. Doesn't matter, right? Build time's 10 times longer. No one will get blamed. If the projects are not migrated, I will be in trouble, right? So I usually don't play C-level people, but so, and lack of accountability, right? What, the CI could be 10 times slower. People wouldn't even know, right? They don't even do the comparison. So you have to get your incentives right? And all I can say that this is not how a mature industry changes their assembly line. I think we all agree on that. It has to change. And by the way, from a DX experience, it's of course very shitty for the developers. Another reason why you want to have usage insights, most organizations don't know how much the tool chain is used, right? And you want to know this for your educational offerings, for possibly phasing things out, right? You want to know where to focus your developer productivity initiatives on. The best people have is analyzing the source repos, right? But that is absolutely not sufficient, right? You need actual usage data. How often is the toolchain used? What are the problems? What is the quality of service? What are the failures, right? What is the return on investment for making certain toolchain usage faster, right? Even it's so obvious, right? Any DX team needs this, and no survey can substitute for this. Finally, why you want usage insight is toolchain consolidation. I think Etienne is giving a talk about this tomorrow, I think, about gaining cross-project build insights. And that it will be one part of the talk. The version spread we see in the tool chains once observability switched on is terrifying, right? The JDK versions used in local development environments, the range is like, wow, right? And it's terrifying, right? It's a security concern, it's a reproducibility concern, and it will definitely lead to hard to debug problems, right? A lot of that is very easy to fix once you know about it, but you need to know about it. One of my favorite topics, right? Pipeline reliability. This is a super interesting and complex topic. So providing the service as promised is a key SLA for your production environment. And this is proactively managed with whatever application performance management practice and product you're using. The reality for the path to production is that the mindset is reactive, right? Developers have to run into failures related to the pipeline. They have to file an issue, and then they get addressed, right? There's no proactiveness wherever I'm looking, right? Unless maybe all of CI is down. Okay, then probably there's some proactiveness. But anything a little bit more complex, no. Developers have to run into the problem, then complain about, or then file an issue, complain about it, right? And then it might get addressed. So, and that is something you want to turn around completely. And obviously, observability is key to this. It goes beyond the scope of today, but this is one of the biggest challenges and biggest adversaries of a good developer experience is pipeline reliability. And it all starts with knowing about your failures and flaky test and what causes them. Again, all starts with observability. Most organizations would have no idea what the different failure categories are, all CI, let alone for local builds, right? So I'm almost at the end. So having seen the impact observability is making to organizations, right? For example, with our product, has made us even more convinced about its importance. So our customers have been asking us to extend our support to other tool chains. So we've been listening and are super excited to announce the velocity support for NPM and Python coming in the first half of 2025. Yep. So please, everyone, do your homework. Make toolchain observability a priority for the local and the CI environment. Do no longer be embarrassed by not even knowing how many builds your organization is running. Right? It will be a gift that keeps on giving. It will create trust between the infrastructure and the developer organizations. It will lead to rational decision-making, impact-driven decision-making, enabling you finding low-cost, high-reward opportunities to improve the developer experience and the productivity. It will be transformational for all of your DX efforts and your development organization as a whole. Thank you very much.